Good afternoon, Year 5s, and welcome to your science lesson. Today is going to be a really exciting lesson because we're going to be looking at doing a little investigation and doing a little experiment. So our learning objective today is to investigate materials that dissolve, and we're going to be looking specifically at what happens to sugar in water. And some of you might have some predictions about that already. That is your big question, okay? Our steps to success involve to be able to know what the definition of dissolving means. So how would you explain what dissolving means? To be able to identify a material that is soluble or insoluble in liquid, and we're going to look at what those terms mean, and to investigate different types of sugar and observe the changes in dissolving speed. Okay, so those are what we're going to be looking at today in our lesson. So first of all, we're going to do our just checking. So I'd like you to pause the video now and to answer those 4 questions for me, which include the type of material that does not allow water to soak through it, a place where an animal naturally lives, where research that is completed in space, and an animal that only eats meat. So if you can answer those 4 questions for me, you can do so now. So pause the video. Okay, so a type of material that does not allow water to soak through it is going to be waterproof. Place where an animal naturally lives is called habitat. The ISS is the International Space Station, where research is completed in space, okay? So the astronauts will fly up to the International Space Station and they will conduct experiments and do things and tests and look at things from up in space. All right, so if you wrote ISS, that's fine. International Space Station. Okay. Go. And an animal that only eats meat is called a carnivore. Right, so there are your 4 just checkings. So let's look a little bit about our powerful person before we carry on with our lesson. So Charles Mackintosh is the person we're going to be looking at over the next couple of weeks and learning a little bit about him. He is a Scottish chemist. And so he deals with a lot of experiments and having to look at different solutions. And he is an inventor of the waterproof fabric material. Okay, so what you have on your raincoats, he is the person who invented that material that when it rains, we do not get wet. Okay, so and there's a picture of him. So he obviously lived quite a number of years ago. He was born on the 29th of December, 1766. Okay, so a very long time ago, in fact. And he then died on the 25th of July, 1843. Okay, so he lived to quite a good age. And there is a picture of him. So we're going to be investigating some things, all right? What happens to salt if you add it to water? So you're going to go and do this little experiment now. You're going to need a glass, okay, it could be a plastic see-through transparent cup even, something like this. You'll need some salt and you'll need some water. And then you're going to take a teaspoon of the salt, put it in the cup and give it a whirl and tell me, what do you notice, okay? All right, so if you just put the salt in, add the water, see what happens, and then give it a stir. So pause the video now, see if you can go get some salt. If you can't find a transparent cup, that's absolutely fine. You can use just a normal cup or a mug, and you'll just have to look down from the top. And then first of all, just put the salt in. Okay, you might need to put quite a bit of salt in, put the water in, put cold water in as well. And then leave it and then give it a stir and see if there's any change. So have a go at doing that as a bit of an investigation. Okay, don't forget to pause the video if you need, otherwise I'm going to continue. So we talk about the word dissolving, okay, and salt dissolves in water, and this means that it breaks up into tiny particles. Particles are very like small pieces, and you can no longer see it in the water, all right? So it becomes what we call a solution. Because you cannot see the pieces of, or the particles of salt, and it has dissolved in the water, it becomes what we call a solution. And a solution is when these two are mixed. Solutions are sometimes colored. For example, you will notice that probably with the salt, it's turned like a very milky color perhaps. And the more salt that you add, the more milkier it will become, okay? However, they are always transparent, which means we can see through it. you can see straight through the solution. So if you look down at the bottom, even though it might have changed a little bit of a color, you'd be able to still see at the bottom of it, okay? When you think about food coloring, if you took different food coloring and you put it into water, it'll change the water. You'll still be able to see through it though. It'll still be transparent. Right, so can you think of any other solutions that you could create? So for example, I've just said about food coloring. What other materials could we put in that could also dissolve? Have a think about that. Pause the video if you need. Otherwise, let's carry on. So when materials are mixed with water, several different things can happen. Sometimes the material will dissolve, or it can react to make a new material. And sometimes it'll just float or it will just sink. Okay, have a look at these materials. Which would dissolve, which one would react, and which one would float or sink when mixed with water. So if you think about sand, sugar, and plaster of Paris is a type of powder that they mix with water, and it creates those casts that if you break your leg, they put them into those cast. So you'll see people who are walking on crutches often have a plaster of Paris cast, okay, either on their leg or if they've broken their arm. You'll see it's that white sort of material. It's not even like a material. It's very hard, and people often write and scribble on them and give notes to the person who's broken that item, and it holds it in place. So it goes very hard, okay, it changes completely. So which one of those three do you think will dissolve? Now, hopefully you have said the sugar, because sugar is very similar to salt in terms of the particles. When we add it to water, it will dissolve. Okay, sand, if you take some sand and you put it in, some of the sand might dissolve. Most of it will probably just sink to the bottom. And then plaster of Paris will create a reaction. Okay, and this reaction is it completely will change what it looks like at the beginning. So plaster of Paris will become hard, and that's how the people are able, doctors are able to put the person's broken part of their body into this cast to keep it from moving. Okay, some of you might have even broken something in your child life, and you would have had to have a cast of sorts, and you would have had plaster of Paris put on. I know it becomes very itchy if you have ever had to have your body, it becomes there. Some people take a pencil, especially if it's like a broken arm, and they take a pen and they try and scratch because they obviously can't get to it. So those are the three, and those what would happen. Right, let's have a look at next. So what did we think, right? So obviously sand, we said sand would just sink in the water. All right, so if you got that, well done. Salt, we would say it would dissolve, all right, and that means it would break up into these very tiny particles, and you would no longer see what the sugar is, okay? All right, and can you remember that word that we used earlier where it changes into a something, okay? When we mix the two together, it becomes a what? Good job, it becomes a solution. And plaster of Paris would have this reaction, okay, and it would react to the water, and so the mixture will turn hard, okay, and that's why they are able to mold it into a cast for you. And it creates a completely new material from its original. So there we go. So when we're looking at dissolving or melting, we need to decide which one is which. Now, dissolving means that it involves a liquid and another material, often a solid, okay, something that is solid. We spoke about solid, liquids, and gases. You've learned about those in your previous years. All right, and a solid is something that often has, is something that like a spoon would be solid, okay? All right, a gas is obviously a type of sort of air mixture, so something like oxygen or carbon dioxide, those are gases, and a liquid is something that obviously can move like water, all right? So in dissolving, the solid mixes into the liquid. So if I had to take the sugar or the salt and put it in, that would be my solid. And then I would take the water, which is my liquid, and when I mix it, that would dissolve, okay? It would make a new liquid, which we call a solution, which is what we did with the salt when we did our little starter. And dissolving doesn't need heat to occur. I don't need to heat up the water. I don't need to heat up what's in here, like putting it on a stove or anything like that. When something melts, melting involves only a solid. So think about an ice cube. An ice cube is a solid. And when it melts, the solid changes into a liquid. So the ice cube goes from being a solid, and when we apply heat, which is what it's needed, then the material will start to melt and it will turn into a liquid. Okay, right. Can you think of substances that you think can melt or dissolve? Have a think about those. And once a substance is dissolved, can we get it back to its original state? Do you think that's true or false? Once a substance is dissolved, we cannot get it back to its original state. Do you think that is true or false? Let me just put that in there. True. Have a think about those. Okay. Have a think. What do you think? Right, just to get your mind ticking. This question I'm not going to go through because we're going to be looking at it in our next week's lesson. So let's see if you can have a think about this one, if it's true or false, and if you're right next week when we come back to it. Right, so our vocabulary for today is we're going to be looking at certain words. A solution we've learned about is when we take our solid and our liquid and we create a new sort of liquid material. So when we took the salt and we added it to the water, we created this solution when the particles dissolve into water or a liquid. Soluble and insoluble. Soluble means something can dissolve and insoluble means it cannot, okay? All right, so often a soluble is something that, think about like a marble. A marble, if I put it in this glass of water, is not going to dissolve, okay? Nothing's going to happen to it. It's actually just going to sink and it's going to stay there. Insoluble means, other way around. Soluble means that it can, so the salt and the sugar, and insoluble means that it can't, okay? So insoluble, like a glass marble, would just sink to the bottom. Soluble means I would be able to make a solution. And if you think about the word solution, here we go, you can see that those first 4 letters and these first 4 letters are the same. So when you're creating a solution, it's obviously when something can dissolve, and insoluble would be the opposite of that. It won't be able to. Reaction is when 2 things are mixed together and it creates something new. All right, so like when we did the plaster of Paris, it reacts to the water. Okay, when we put it there, it reacts and it creates a new material. Dissolve, as we've known, it means it can obviously change and it can go into a solution, and melting means that it's, if you apply heat, the solid will then melt. Okay. Right, so today we're going to be investigating how different sugars dissolve in water. So what you're going to do is you're going to need to help me out here today, because you're going to need to go and get some sort of a timer. It could be a watch, it could be your parents' phone, if you have your own phone, and find the stopwatch. And you're going to have to draw this table on your piece of paper because you're going to need to record these results. Okay, so you can pause the video now and you can go and get all those things ready so that you're ready for the experiment. All right, so I'm going to let you pause now. All right, and then have it, make sure you've got all those things. Okay, so when we're looking at this experiment today, we need to think about how we can make this test fair. All right, and so which means what can I do to each of these cups when I'm adding the sugar to make sure that it's fair. Okay, so it could be things like making sure that I'm using the same teaspoon and that I'm measuring out the same amount each time. It could be that I'm going to be putting in the same amount of water for each cup, okay, that I don't fill one cup all the way up to the top and the other cup only halfway. So talking about how much water we're going to add. It could also be how many stirs I'm going to do each time, because the more I'm stirring it, the quicker it's going to dissolve. Whereas if I just left it, it's going to take a lot longer. So that is some of the ways that we're going to make this test fair, so that what I'm going to do to each sugar is going to be exactly the same. So hopefully you're ready with your stopwatch, okay? Unfortunately, when we were at school, we would have been able to do this in our teams and it'd be a lot of fun, but you're going to help me out today because I can't do 2 things at once. So make sure you've got this table. We're going to be looking at 4 different types of sugars, and we're going to be then recording the time it takes to dissolve. Okay, so you're going to watch me very carefully now. I'm going to turn this around. And I'm just going to set up my work. So we've got 4 different types of sugar. We've got our brown sugar, which looks like this. Okay, you can see in the color is actually quite brown. right? I'll show it to you a little bit closer later. First one, we've got our sugar cubes, which are exactly like that. They are in cubes. We have our granulated sugar, which is like your normal sugar that you have on your table. And we have some powdered sugar, which is the sugar we use to make like icing. Right, and you will notice that it is very, very fine. Okay, so before we start, have a little think about a prediction. Which one do you think is going to dissolve the quickest? Do you think the powdered sugar, which is very fine sugar, or do you think the cube will go the quickest, or the brown sugar? So have a think before we start. Okay, so I'm going to stop sharing now, and hopefully that'll be nice and big for you to see. Just move that back. Right. Here is my beaker of water, and I'm going to just have a seat here. Okay, so we're going to start. You don't really need to see my face. It's more important that you see the different items. But I'm going to get my cups ready. So the things we're going to need in order to complete this experiment are some cups. Okay, it doesn't really matter if they're not transparent. You can also do these experiments at home afterwards if you'd like. Remember, it's always going to be different times, probably not going to be exactly the same because you might add more sugar or less sugar. You might add more water or less water. So your test could be different. So you're going to need 4 different cups. Okay, 4 cups. Put that there. All right, you're going to need a teaspoon. All right, now my teaspoon is also quite a big teaspoon. If I have a look at this teaspoon here, this one is much bigger than this one. So making sure I'm using the same teaspoon to level out the sugars. I'm going to need some water, and I'm going to need my 4 different sugars. So the first one we're going to do is our brown sugar. So on your piece of paper, can you write brown sugar so that you know that we're going to be looking at brown sugar? And we're going to take 1 teaspoon of brown sugar, and you can see if I hold it up to the camera, you can see it's quite gray, it's quite brown, and you can see that the granules are actually quite big. I don't know if I can get it any closer. Okay, so I'm going to put that teaspoon in. Remember, I'm trying to make sure that I'm giving the same amount each time. Right, so it's in. And as soon as I start pouring, you're going to start timing for me, because as soon as that water hits, it's going to start reacting to the with this sugar, and it's going to start dissolving it. So have your stopwatches ready for me. And as you see me pour it, you can then start recording. So let's just get this out of the way so that you can see it nice and clearly. Right, here is my sugar, and I'm going to do it sort of halfway. I'm going to measure it halfway. Right, and go. Right, and now I'm going to give it 10 stirs. 1, 2, 3, 5, 6, 7, 8, 9, 10. And I'm going to watch it. Okay, and it's taking quite a long time to dissolve. There's quite a few granules at the bottom still. Okay, I hope you keep timing all of this, making sure that you're keeping up the time. I'm going to wait, and then I'm going to do another 10 stirs. 1, 2, 3, 5, 6, 7, 8, 9, 10. Right, and now it has dissolved, okay? So stop your watch and write the time down there for me. So that is the brown sugar. You can see it sort of changed the color as well as from the water. So we've made a solution there. Okay, so you can see it's still transparent. I can still see through to the bottom. All right, you could probably still see through it. Okay, there you go. You can still see the lights coming through. All right, you can kind of see my finger on the other side. You can still see through it, but it is now a slightly different color. So that is the brown sugar. So write your time down for the brown sugar. The next one we're going to do is our cube of sugar. Now, this is quite solid. It's been compacted together, all the little sugar particles. Okay, so let's see how long this one takes. So get your stopwatches ready, get your timers ready. Again, I'm going to measure it with this one. So I'm making sure that I'm going to try and keep the amount of water that I'm giving is the same. Let me just get it so that you guys can see it as well. Right, and go. Right, you can see very little has happened. Nothing has happened, in fact, but I can see tiny little bubbles starting to form because there's obviously little air pockets between the cube, and I know that it's going to start dissolving soon. Right there, it's starting to dissolve. I'm going to do my 10 stirs. 1, 2, 3, 4, 5, 6, 8, 9, 10. Okay. Right. Still, there's a big piece. I don't know if you can see it, but if I show it to you, you can see there's a big piece still that hasn't been able to be dissolved yet. I'm going to give it another 10 stirs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, there's still a little bit more left at the bottom. I keep timing it. Right, and I'm probably going to need another few stirs. Another 10 stirs, and now it has dissolved, and you can see it's gone a bit of a milky color there, and that has taken quite a while for that sugar cube to have dissolved. Okay, so stop your watches. I would say it's all dissolved now, and record your time for me. Okay, the next one is our granulated sugar. This is like normal sugar that you would probably find in your house. And remember, I'm using the same teaspoon. I'm making sure that I'm the same level of sugar, 1 teaspoon. Right, and get ready to get your stopwatches ready. I'm just going to put that one next to it so I can measure it out that it's the same. Okay, and go. Right, so we're going to do 10 stirs. And actually, I don't even need to stir it. You can stop your watches. It's all been dissolved. All gone already. So there we go. That's how quick it was. Done. Right, so that's our granulated sugar. And the last one that I'm going to do is our powdered sugar. Right, so get your stopwatches ready. There is my teaspoon of powdered sugar. Right, and try and measure this more or less the same, and go. Right, now there's still a bit more there. Keep going. And I'm just going to do maybe 2 stirs. Right, and stop right there, and you can see it's created a solution. Right, so there are your 4 sugars that we've done. Okay, and those are your experiments. So you're going to log on to Teams now, and you're going to complete the activity. You can also do these experiments at home, so you're welcome to try it out yourself. So good luck and enjoy. Hope you enjoyed your lesson. Well done, guys.